Hello, I'm happy you're about to watch this video. This video is based on a Telegram class that was held on the 20th of May 2020. So if you were part of the class or you were not part of the class, I'm sure you are going to learn a lot of things watching this video. And please don't forget to subscribe, like and share after watching this video. We use electricity in our everyday life. Your TV, decoder, fan, air conditioners, washing machine all use electricity. What you call electricity is actually charges moving. Your fan works because charges called electrons move through wires to reach your fan for it to work. You cannot see these charges with your naked eyes, but you can feel them when you touch a live wire. And please don't touch a live wire. This is a warning. What then is electric current? Electric current is the rate of flow of electric charges through a conductor or circuit. Electric current in physics is usually measured in amperes. And if you want to measure it, the instrument used to measure electric current is ammeter. So an ammeter is used to measure electric current, and the unit whenever you measure electric current is amperes. When the current you want to measure is very small, let's say the current is less than 1 ampere, then you can use a milliammeter, a microammeter, or a galvanometer. If you want to measure the current flowing through a device or a component, let's say a resistor, you connect the ammeter in series with the device. In this picture you are looking at, the device is the resistor. So the ammeter is connected in series with the resistor. Ammeters are usually connected in series with the device or component whose current is to be determined. Before electric current can flow from one point to another, let's say for example from one end of a wire to another, there must be a difference in potentials. This difference in potentials is what we call potential difference. Another way of looking at potential difference is this. The potential difference between 2 points is the work done against the electric field in moving unit charge from one point to the other. For a battery, the 2 points are the positive terminal and negative terminal of the battery. Potential difference is measured in volts, and a voltmeter is an instrument used to measure potential difference. Unlike ammeters, voltmeters are usually connected in parallel with the device or component whose potential difference is to be determined. Components connected in parallel with one another have different current flowing through them. So if you look at the picture right now, the current flowing through the voltmeter is different from the current flowing through the resistor, although the voltmeter measures the potential difference between the two ends of the resistor. The highest potential difference that can be generated by a source of electric current is known as the electromotive force, EMF. For a battery or a cell, the EMF is the potential difference between the terminals of the cell or the battery when the cell or the battery is not connected to anything or an external circuit. So when you have a battery or a cell that is not connected to anything, the highest potential difference you get between the terminals is the electromotive force. Another way of looking at electromotive force is this. The electromotive force is the total energy that can cause current to flow in a circuit. Just like potential difference, electromotive force is measured in volts. It is not only a battery that is a source of electromotive force. Other sources of electromotive force are solar cells, electrical generators, and transformers. A good example of electromotive force in your everyday life is this. If you buy a new battery like the ones used in your remote control, that is, if you buy a new battery like the ones you use in your remote control, you will see 1.5 volts written on it. That 1.5 volt is the electromotive force. When the battery is working, let's say for example you have inserted that battery in your remote control, the potential difference from the battery is no longer the EMF. That is, when the battery is already working, the potential difference between the terminals of the battery is not the EMF. Let's talk about resistance. If you try to pass electricity or electric current through a material, the material will resist or oppose the flow of the electric current. This opposition to the flow of electric current by a material is called resistance of the material. When the resistance of a material is so low that current eventually passes through the material, then that material is a conductor. Conductors allow current to pass through them easily. They have low resistance. Examples of conductors are copper, iron, silver, and aluminium. Materials that do not allow current to flow through them easily are called insulators. Insulators have high resistance. If you look around you right now, you are likely going to see some insulators. Objects made of plastic, ceramic, rubber, and glass are insulators. So, like I said earlier, resistance of a material is its opposition to the flow of electricity. And resistance is measured in ohms. You can see the symbol in the picture. So if, for example, you are asked which one can oppose current more between 7 ohms and 100 ohms, meaning two different materials. One is 7 ohms, the other one is 100 ohms, and you are asked which one of them can we oppose current more, the answer will be, do you know what the answer is? The answer will be 100 ohms. The bigger the resistance value, the larger the opposition to the flow of electric current. That is why insulators have high resistance. There is a law in science that shows the relationship between the electric current passing through a conductor, the potential difference between the ends of the conductor, and the resistance of the conductor. This law is called Ohm's law. Ohm's law states that the current flowing through a metallic conductor, which could be a wire, is directly proportional to the potential difference across the ends of the conductor, provided the temperature and other physical conditions of the conductors are kept constant. So for Ohm's law to apply to a conductor, the temperature and other physical conditions of the conductor like stress, strain, and others must be kept constant. It is not all conductors that obey Ohm's law. Conductors that obey Ohm's law are called ohmic conductors. They include metals such as silver, copper, aluminium, and iron. Some conductors do not obey Ohm's law. Such conductors are called non-ohmic conductors, and they include diodes, filament bulbs, and vacuum tubes. Now this is an example on Ohm's law. A car fuse is marked 15 amps and operates on a 12-volt battery. Calculate the resistance of the fuse wire. So from the question, we're given the current, and the current is 15 amperes. Then the potential difference from the battery is 12 volts. According to Ohm's law, the potential difference is related to the current through this equation V is equals to IR, where R is the resistance we are looking for. So we are going to insert our values. So our V is 12 volts and our current is 15 amp, then multiplied by the resistance we are looking for. So if you divide both sides by the current, which is 15 amp, you are going to be having 12 volts over 15 amp is equals to 15 amp times the resistance over 15 amps. Then on the right hand side, 15 amps will cancel 15 amps. So we have the resistance is equals to 12 volts over 15 amp. If you use your calculator, 12 divided by 15 will give you 0.8. Resistance is measured in ohms, so I'm just going to put ohms here, and that will be your final answer. Factors that can affect the resistance of a conductor, like let's say a wire, include number 1, the length of the conductor. The longer the conductor, the higher its resistance. Another factor that can affect the resistance of a conductor is the area of the conductor. The larger the area of the conductor, the lower its resistance. The third factor that can affect the resistance of a conductor is the temperature of the conductor. Resistances of some conductors get higher as the temperature increases. If we consider the first two factors I mentioned earlier that affect the resistance of a wire, that's the first one, we said the resistance of a wire is proportional to the length of the wire. Then the second one, I said that the resistance of a wire increases as the cross-sectional area decreases. So if I do this and I combine both, you're going to have resistance is proportional to the length of the wire and inversely proportional to the cross-sectional area. Okay, then introducing a constant, you are going to have R is equals to this L over A. Now this constant is the resistivity of the conductor or of the wire. And if you do the reciprocal of the resistivity, that is, if you do 1 over resistivity, you are going to be getting the conductivity. Conductivity is measured in Siemens. Here is an example on resistivity. A resistance wire of length 2 meters and of uniform cross-sectional area 5 times 10 to the power 7 meters square has a resistance of 0.25 ohms. Calculate its resistivity. So from the question, the length of the resistance wire given to us is 2 meters. The cross-sectional area, which is A, is 5.0 times 10 to the power 7 meters square. Then the resistance of the wire is 0.25 ohms. So we are going to apply the relationship between the resistance of a wire and the cross-sectional area and the length. So the relationship, that's R equals the resistivity multiplied by the length of the wire divided by the area or cross-sectional area of the wire. So what we are going to do now is we are going to make resistivity, which is this, we are going to make it the subject of the formula. So if you do what we call cross multiply, you have RA is equals to resistivity multiplied by the length of the wire. If you make resistivity the subject of the formula, you are going to have resistivity is equals to RA over L. That is, when you divide both sides by L, you are going to get RA over L. So if we insert our values, we are going to be having our resistance given to us is 0.25. So I'm just going to write that. Ohms multiplied by the area is 5.0 times 10 to the power 7 meters squared over the length. So what is our length? 2 meters. So I'm just going to put 2 meters here. Then if you look at the units, meter we cancel 1 meter here. So 1 meter will be left. Ohms will also be here. So if you use your calculator and you carry out this, you are going to be getting 6.25 times 10 raised to the power 6 ohm meter.